So this is, oh, and I realize like that there's this vast light problem behind me. Um, Let me see if I can pause this and fix the light problem. All right, this is me trying to fix the lighting. So this is the recording for the missing day of January 21st, 2025. So I need to do some share screen stuff. Um, which also then means I need to figure out where my notes are for all of this. So yeah, I'm being crazy disorganized. Let me put this on pause. All right, so let me see if I can pull up my whiteboard, and I am going to draw some stuff on it, providing this thing actually cooperates. So we have been talking about functional groups. And pen thing. And we'll see if this lets me draw stuff. All right, so if I am drawing a molecule, so CH3, and then we have a CH, and then we're going to put one C up this direction and one C down this direction, and put a CH3 there. Make this one be a CH2. And out here on the end, put an O and an H. All right, so one of the things that we were talking about earlier was identifying this as a functional group. So because it has the OH on it, this is going to make this an alcohol. That way, you know that you have all carbons and hydrogens, but the thing that is notably different is the fact that there is an O and an H. So clear page. How about if we do, I need to go back to the drawing bit. Okay, so let's do, and my hexagon is super lopsided, but it will serve the purpose here. All right, we're gonna put, this is not a benzene because it only has one double bond. But then we're gonna put another bond and put a C and a double bonded O. And then we'll put an N and an H2. So it is alkene over on this part, but it is amide over on this part. So it actually has two separate functional groups in a single molecule. And you will notice that there is a little bit of your homework that is along that line. So let me close out the whiteboard, and we're going to talk about naming for a few minutes. So one of the things that is true here is when you are naming, and we are concentrating on just hydrocarbons, when you are naming them, you want to name the longest chain first. If you have branches, then you have to not only give a location, as in a number, and the name of the group. But you also want to not necessarily go from left to right, because left to right might not give you the lowest numbers possible. If there is more than one branch, and if those branches are not the same thing, then you are also required to alphabetize them. So I have a few examples here to talk about. Eventually, next week on Thursday, I'll also kind of backtrack and give you a few more examples on the board. But this is so that you're getting some information, and then we'll kind of, like I said, go back to this a little bit. So if we look at CH3, two CH2s in a row, and a CH3, so 4 carbons. It is all in a straight line. It has no branches. It is butane, as in the stuff that is lighter fluid, because the BUT is the representative of 4 carbons, and then the ANE is what indicates that it is an alkane. If I look at the next one, all right, we're going to kind of start at that end and go, okay, let's, at least for the moment, call that number 1 on the carbon end of things. Then we have number 2 carbon, number 3 carbon, number 4 carbon, number 5 carbon. And note, this one is not part of the main chain. It is a little twig off of the main chain. It is a solitary 1 carbon group. Therefore, it goes by the name of methyl. So it's same prefixes. We're changing the end. We're making it YL on the end. So we have a number 3, an indication what the twig is, and then the name of the main chain, which is 5 carbons long. Therefore, it is a pentane. If I scoot down a little bit further here, we've got some other examples here. If you look at the one that is the first upper left-hand one here, we've got 1, 2, 3, 4, 5, 6. You could also go 1, 2, 3, 4, 5, 6, and go up and over. And either way, you get the same length of chain. You're trying to maximize your chain length. So we have 1 branch that is a single carbon, 1 branch that is a pair of carbons linked together in a very small chain. So I actually ended up naming this so that the ethyl, because alphabetical, remember, comes before methyl, but each one has to have a number. So it's like an addressing system. 4 ethyl, 2 methyl, and then at the end, you put the name of the chain. So hexane. If I look at the right-hand one there, we've got long chain across. Let's double check and make sure if that's the longest one or not. So 1, 2, 3, 4, 5, 6, 7. Okay, that's the longest version. There's a 1 up and 1 down. But then there's this little two twig chain. Okay. I can use the same number twice, but I also have to write it twice. So 4 ethyl, and this time I'm actually numbering from the right hand end. I'm kind of backtracking from the right hand end of the molecule over on this end. and going backwards so that I end up with slightly smaller numbers than if I had started from the other end. So 4-ethyl 3,3-dimethyl. So there's all these little variations on a theme, and I just tried to give you some examples. And like I said, we're going to kind of walk through some on the board in addition to this, but this gives you a starting point for, okay, here are some examples, and here's some of the guidelines so you can begin to absorb them. If I'm naming the numbers and the names, ethyl, methyl, propyl, etc. Actually, I should say methyl, ethyl, propyl, butyl, will give you what they are, but you can use dies and tries to tell you how many. If we look at the one down here in the middle of this box that I kind of highlighted up here, it even gives you some of the numbers. Like, oh, if you go across and that's 7, you could try to go downward. That's also 7. But you get better numbering if you do the 2,3,5 trimethyl 4-propyl heptane. We will also encounter, and note the one here that's kind of in the middle on the right-hand side here. Notice it has this weird little thing in it that says cyclo. Okay, cyclo means somewhat circular. Doesn't have to be an exact circle. Okay, it just has to have like a beginning and an end that join together. We're actually going to see some of this in lab also when we do the Tinker Toy lab. This one is cyclopropane. So 3 carbons, that's your propane part. Cyclo, because it's not just a string, it's a little triangle. And then there's a little twig sitting on top of it that is a methyl. When they are in a circle, you usually do not number them, because then you would have to decide where your numbering starts. So most of the time, if they are cyclo in nature, they are not going to be numbered. A couple more down here at the bottom. So this one's a long, skinny one, okay? If you count all the way across, okay, you actually get 9. So nonane. It has 2 little twigs, okay, so 2 and 7 dimethyl. But then it has this big kind of irregular twig, which if you go and you check at the other hydrocarbon handout that's loaded to the pages, you will see is known as a sec-butyl. So this one's actually kind of a symmetrical molecule in a lot of ways, because if I started at the right-hand end, okay, I get a 3. But if I start at the left-hand end, I get a 2 as my smallest number. So it is numbered left to right. In the far right-hand corner one here in the box, we've got, oh, okay, 6 cross. We're gonna actually number this one from the right-hand end so that the ethyl ends up with a smaller number than the methyl. Each time, all of this really, really, really revolves around how many carbons and where the branch is stuck on. We're not naming alcohols, amides, amines, ketones, all of that. We're not naming those things. We're only sticking to hydrocarbons. We'll do a little bit of alkene and alkyne, but not an extensive amount. Here's another one down here at the bottom of the page that gives you, okay, straight across is your octane. E here's your alphabetization. This is kind of a nasty looking molecule. You have 3,3-diethyl. So one branch up, one branch down at the number 3, counting from the right-hand end. You have one that drops down. That's your methyl. And then you have this isopropyl one, which is the little split one. And it's at number 5. Let me go back to the whiteboard and draw one from scratch so that you can kind of see where I'm going with this. All right, so actually, let me do this. I'm gonna do my font size bigger. All right, so we're gonna do some CH3 dash CH. Oops, that was not supposed to be a plus sign. I can't do subscripts, not with any kind of ease here on the whiteboard. So it looks like they're not subscripted down when actually they're supposed to be. Let me go back. Take out one heart, one of those, and I'll switch back over to drawing. Drop one down, and we'll put a CH3 on here. All right, so when I am looking at this molecule, okay, I am gonna look at the long chain and figure out how many I've got. So I've got 1, 2, 3, 4, 5, 6. It's a hexane. So back over here to text things. So we know it's a hexane. It's got some other stuff going on. Okay. It's also got this. This is an arrow just for reference purposes. It's also got the double bond down in there. So it's truthfully not a hexane. It's actually a hexene. So if I want to be more correct, because I needed to have like a starting place for this. So hexene. Oops, there actually needs to be an hexene in there. So I need to indicate where my double bond is. All right, if I started from this end, it would be 1, 2, 3, 4. No, that's probably not a good idea. Probably better to go the normal left and right. 1, 2. So this is a 2 hexene. And we've got this little twig down here. But if that's number 2, then we've got 1, 2, 3, 4, 5. So the other part of our name squish over top of it. Let me raise it up a little bit. All right, let's do 5 methyl 2 hexene. The fact that it's a hexene takes precedence over the branches because that's the base compound. Then I indicated where my twig was, so it's on number 5. And the whole thing together then becomes 5-methyl 2-hexene. And I should probably actually have another dash in there and make it all one long string. I have sort of frustrations with the way the whiteboard works. There are kind of limits to how easily it is to draw stuff on it because it's all kind of controlled by my touchpad as opposed to I don't have a drawing pad that has a stylus. So I kind of have to do it the other way. All right, so one of the things that's going on here then is we have all these different types of um, hydrocarbons. You're looking at chains. You're looking at um, what kind of bonds are present: alkanes, alkenes, alkynes, aromatics. You're numbering the things that go there. Doing the lab that actually is in approximately 2 weeks actually helps a lot, because sometimes not having sort of the tactile component makes it really harder to figure out, oh, okay, if I'm like putting this all together, which direction am I counting from? Yeah, there's a lot of chaos involved there. So this gives you some backup then to finish off the end of what this chapter is for organic. We're not going to do, there is a little bit more in your textbook that we are not going to cover. I am not going to make your homework due on Thursday because I want to be able to answer questions before I have your homework due, but I recommend go ahead and work on your homework so that you can ask me questions when I am back on campus on Thursday. And then we'll cover a little tiny smidge of the coordination compounds, and then we're going to kind of hop back over to the more normal sequence of the textbook and do some of chapter 10, probably a little bit also on Thursday. And then, of course, we have lab on Thursday too. So I'm going to cut off the recording and see if I can convert this over and load it to Zoom, and then I will put it on YouTube.